Welcome back. This is Mr. Thompson again. We're looking at the problem set from section 2-3, pulling out a few problems about limit theorems. So these are from pages 43 to 45. I'm going to go ahead and look at a few problems that I picked out. So first problem is number 9 on page 44. This gives us a function r of x equals x squared minus 4x minus 12 all over x plus 2. Now the instructions say to graph it on the grapher, show that the function takes the indeterminate form 0 over 0 as x approaches the given value, then simplify the fraction, find the limit, and that's pretty much it. And prove your answer is correct by naming the limit theorems used as each step. So basically we're looking for a removable discontinuity. If it looks like this, if we're getting the indeterminate form, that's what we want. So we want to see it as x approaches -2. Now plotting it on a grapher, you should do it. I'm not going to worry about doing that right now because what I want to focus on is simplifying the fraction, finding the limit. So first step, prove its indeterminate form. R of -2, let's see, -2 squared minus 4 times -2 minus 12, all over -2 plus 2. Bottom is obvious, it's 0. Let's see, -2 squared is 4, plus 8 is 12, minus 12 is 0. Indeterminate form. Now, indeterminate form means we have a removable discontinuity, means we are going to simplify the fraction. So what that means is I need to figure out what is left after I cancel out the x plus 2. Now all I have to do is factor a regular quadratic, not a cubic, so I shouldn't have to do synthetic division for that. So there is a trick that I've used in the past called x factor. So if I have my quadratic x squared minus 4x minus 12, let's see, minus 4 goes up here, minus 12 on the bottom. I need to think about what two numbers add up to -4, multiply to make -12. Now this trick only works given easy numbers, but I'm going to go ahead and use it now. I can see that it's going to be -6 and 2. -6 times 2 is -12. -6 plus 2 is -4. So factored form, this turns in to x minus 6, x plus 2, and then the bottom is x plus 2. X plus 2 is canceled. My newly defined function r of x is just x minus 6. That's all that's left. So I want to know the limit as x approaches -2 of r of x. Well, if I plug -2 in here, -2 minus 6 is -8. Okay, pretty simple. All we have to do is factor, cancel, plug in. Okay, series of steps. Each one you've known how to do. It's just combining them into a new system. Now, let's go ahead and look at another problem, pretty similar. Number 11 from the same page, right next to it. Let's see. This one gives us a cubic, f of x equals, cubic on the top, x cubed minus 3x squared minus 4x minus 30 all over x minus 5. And we want to know as x approaches 5. So first step, make sure it's indeterminate form, which means f of 5 needs to equal 0 over 0. So let's see, 5 minus 5 is 0 on the bottom. 5 cubed is 125. Minus 3 times 25, so minus 75 is 50. Minus 20 is 30. Minus 30 is 0. Indeterminate form. So pretty easy to find indeterminate form there. Now, to get rid of the removable discontinuity, we have to use synthetic division. So I'm going to divide the top by x minus 5. So x cubed minus 3x squared minus 4x minus 30 divided by x minus 5. So to make x into x cubed, I multiply by x squared. So I have x, that should be a 3, x cubed minus 5x squared. Subtract. I get 2x squared, and then bring down the minus 4x, to make 2x squared out of x, I multiply by 2x, so 2x squared minus 10x. Subtract. Those cancel. Negative 4 minus negative 10 turns into positive 6x minus 30. So to turn x into 6x, I multiply by 6. 6 times x is 6x, and nicely done. 6 times negative 5 is negative 30. When we subtract, those cancel, no remainder. This is what we have left. So factoring out the x minus 5, what we have left is x squared plus 2x plus 6 divided by x minus 5, cancels out. Our newly defined function is what's left. So f of x equals x squared plus 2x plus 6. So we want to know the limit as that approaches 5. So I'm going to write that down here. Limit as x approaches 5 of x squared plus 2x plus 6. We'll plug 5 in. 5 squared is 25. Plus 2 times 5 is 10. 25 plus 10 is 35. Plus 6 is 41. And that's your answer. Okay, same as the last one. You just have to use synthetic division this time because it is a cubic that you are simplifying. Now, let's go over one more example of the same type. Practice makes perfect as long as you're doing it right. So next one we're going to look at is number 13. Straight down from the last one. Now I'm picking the odd ones because they're easy to check your work in the back. F of x equals, we have x cubed minus 4x squared minus 2x plus 3 over x plus 1, and we want to see as x approaches negative 1. First step, indeterminate form, plug in negative 1. The bottom, negative 1 plus 1 is 0. The top, negative 1 cubed is negative 1. Minus 4 times negative 1 squared, that'd be 1. So 1 minus 4 is negative 3. Minus, minus 2, and then plus 3, that does turn into 0. And this is going to be indeterminate form. Indeterminate form means we have a removable discontinuity, and so we need to find that by factoring this cubic up top. Since we're factoring a cubic, we're going to do synthetic division. So top in the box, x cubed minus 4x squared minus 2x plus 3 divided by the x plus 1 on the back, or on the bottom. Turn x into x cubed is x squared times x is x cubed times 1 is x squared. Subtract. Cancels. Negative 4 minus 1 is negative 5x squared minus 2x. Turning x into negative 5x squared is minus 5x. Times x is negative 5x squared times 1 is minus 5x. Subtract. Those cancel. Negative 2 minus negative 5 turns into 3x and then plus 3. To turn x into 3x, we multiply by 3. 3 times x is 3x. 3 times 1 is 3. And once again, since we've done this correctly, everything cancels out. We are left with 0. So what we have left is on top. So the factored form, x plus 1 and x squared minus 5x plus 3 all over x plus 1. X plus 1's cancel. Our newly defined function, f of x, is x squared minus 5x plus 3. And so we want to find the limit. I'm going to go ahead and make some room here so I can put it across the bottom. Get rid of this part so I can put some answers across the bottom. So we have the limit as x approaches negative 1 of x squared minus 5x plus 3 equals, well, negative 1 plugged in, negative 1 squared is 1. Negative 5 times negative 1 is 5, and then plus 3. So 1 plus 5 is 6, plus 3 is 9. So that's it. On each of these, we're just looking for the removable discontinuity. So we proved indeterminate form, factored, canceled, simplified, and plugged it in. Pretty simple. Okay, that's it for lesson 2.3's problem set. Most of the rest are pretty much the same way, except for there's some difficult word problems in there. Let me know if you need help with those. I'm going to go ahead and end this one and look at lesson 2-4.